afternoon. This is Liam Recorder, instructor of the cybersecurity program. Welcome to the first section of logging and monitoring. This week, we are going to look into the basics of logging and monitoring and look through the first 5 lessons of the course, which will cover some basics. We'll cover logs. We'll look at how to analyze different log files, and then we'll also look at how to interpret them. And then we'll do some initial discussion, a little more in depth and a little bit more about the different ways it can be used. Discussion of IDS and IPS to set us up for next week, where we will spend a couple lessons on Snort, learning how to configure it and customize it and create our own custom Snort intrusion detection rules. And then we will spend a couple lessons looking at both commercial and open source versions of the big information systems. We've defined these phrases before in like system administration, but NSM, network security management, or SIEM, network security incident and event management, and then or unified threat management. And while there are specific, especially commercial versions of these things, and sometimes this is used as they're sort of branding these names, the reality is that ultimately there's also open source options where you kind of build your own, bring together a bunch of the tools that you might need. We'll expose you to some of those tools. And then our last chapter for a lesson for next week is forensic analysis. And so that will be the breadth and depth of the logging and monitoring course. So to begin with, we just in the first chapter, which is not uncommon, we set some basics, a little review, a little bit of repeat. And so we talk about, which I've just defined most of these, network security management, or security incident and event management, or unified threat management. We also talk about syslog servers, and another concept that's what's called a mirror tap, which, if you remember from network defense, we introduced the concept of port mirroring, and we actually set up port mirroring on the Open vSwitch so that we could set up Snort as an intrusion detection system in a passive mode. We'll learn more about that and other ways we can use that in this course. But another option is a mirror tap, and a mirror tap is actually a piece of equipment that you can plug into a network, and thus it can then mirror that information from that cable. So it's basically like the information comes in, it gets mirrored off, and it passes through. And this is actually pretty hard to detect unless you can physically, put your eyes on the tap. Of course, by the same token, it also means they have to have physical access to place the tap in. But depending upon how things are cabled or how things are secured or not secured physically, then this can be used. It also can be used for monitoring and maintenance purposes. So we can install one of these taps into a place. Maybe we have a part of our building, an older part of our building, that our switch doesn't support port mirroring, but we would like to put intrusion detection on this segment, and so that would allow us to do so. Then after sort of defining some of those terms and some of those topics and covering some of the intro concepts of logging and monitoring, we then spend some time talking about the setup for the course. Now, the setup for how to set up the virtual machine, just so you know, those are the exact same instructions that came out of Network Foundations. The reason that they were included is because we do occasionally have people who take custom versions of our course offerings, either through us or through partners, and so they may or may not have had the Network Foundations course. And so there will be a need to have a standalone Ubuntu machine to look at the logs and do certain exercises in this course. Much like how we did in Network Foundations, we worked either with GSN3, which will work a lot with GSN3 like we did in Network Defense, in this topology we now built onto, but we also will work with some standalone VMs. And so if you don't already have one, or if you messed yours up playing with it, then you can follow those instructions to create a new one. Otherwise, if you have the one from Network Foundations and start in good shape that you can still use it and log in, remember what the password is, then you can, of course, use that, and technically you could use any other flavor, but we're just keeping it consistent and sticking with the Ubuntu. Now, when it comes to the setup for the course, once again, the instructions in large part repeat what was the initial setup for network defense. The network defense class, of course, we had to add all those appliances in to make them available with NGSN3, and then we had to import that project. Well, once again, it's still coming off of my server. The link is in the material, and I believe maybe in the LMS too, but I think it's just in the material since I finally got it put there for now. Until we find the permanent was use home, I'm still hosting it on one of my personal servers, but you'll see that there is a logging and monitoring, or a logmon based topology that you will use. It pretty much is where you left off with your log and with your open topology from the network defense class. But I kind of recommend you just go ahead and use the new one and start clean. And then the same principle applies, that you would import this new logging and monitoring baseline. The main change is that the port mirroring has now been done and the intrusion detection has been installed, but it's basically like the open starter beyond that. And then you will immediately do a save as, so you make your my exercise version so you can do your work in that one and leave the original as the baseline. And then of course, if you want to back up the project in case you mess something up, you can always bring it and re-import it again. And so the setup instructions are a little redundant. You don't have to install the appliances. There's no new ones. It's all the ones you already have from Network Defense. If you've taken Network Defense, of course, and you should. In this case, I know who the student in this case is. Like I said, the materials do reference that in case somebody was taking a custom version and they maybe were just taking some of the more advanced, and they could just start right then and pick up. And so I do recommend you go ahead and re-import the new topology as a baseline, but you could theoretically pick up with the one you had ended the open version of the original version you ended Network Defense with. This will just give you a nice starting point for consistency, especially if you've played around with any of that other stuff. So that's lesson one, is to basically make sure you have a running Ubuntu VM. You can follow those instructions if you need to, or if you know how to get into your existing one, that's great. And then you can set up the topology for this class by importing that portable project in, doing a save as, and having your own exercise version that you can play with. Excuse me. This is my 5th back-to-back lecture today, and it's an allergy season killing me. So then in lesson 2, we titled it Logs, Logs, Logs. Had a little fun with Rhyme of the Ancient Mariner and the text. Put that aside. We talk, at least conceptually, initially about what logs are. I won't go through that whole exercise because it's a little basic, but I wanted to make sure we had that level of basics. We sort of virtually take a checkbook and sort of imagine it, what it would be as a log. And when you get down to it, that's what logs are. They're just logs, they're records of transactions that have happened. And they can be all kinds of different logs. The system itself, the operating systems we use, Linux, Windows, etc., they create a lot of logs just at the operating system level to keep track of errors and things that happen, logins and things like that. And then, of course, various applications, many applications, especially server applications, use and use a lot of different logs. So like web logs, we would have both the access and the error log for a website or websites. We would have mail logs for the mail servers. We might have database logs, intrusion detection logs, all different kinds of different logs. And we take you through a high-level review of all of those after doing the conceptual sort of thought exercise of turning a checkbook into a log. Most of them, at the end of the day, are either one of two things. They're either just plain text. Most of the time on Linux, they're plain text files. There are a few exceptions, but usually they're just some kind of delimited text file. And then whereas on Windows, we tend to find that they have a tendency to be databases more often than not, though they would look and feel pretty much the same. A row would be one record of information, and each column would be a field of information. And so whether that's just in text or that's in a spreadsheet or that's in a database, it doesn't matter. It's the idea that each record is giving you one transaction and all the information about that. So that might be one request for one specific piece of a web page. It might be the transaction of one mail server transferring a mail into another mail server, or one client checking and getting their mail from the mail server. It might be the log of one login or the startup of one process. whatever it is, that information is stored in either generally a text or some form of a database format. And then, of course, it's almost always the case that there's some kind of time and date stamp there to give us that information. And one of the reasons it's so important to keep machines up to date and ideally have them synced to some kind of time server NTP protocol, so that which is more the default these days for phones and devices, but other legacy equipment sometimes doesn't have that ability, or it's not built in directly. You have to add it, or if nothing else, you got to manually make sure these things stay in sync. It's very important for network security that we keep time sync, so we know when things happen and we don't have any unaccounted for time. That could be a chunk of a log that's been deleted, for example, to cover the tracks of something. And so if we don't have accurate time counts or time stamps in our logs, then we may not be able to notice that. And so that is one of the common things. And then the rest of the information kind of varies, of course, depending upon what the log is. If it's a login log, then it's going to have username information, time they logged in. If it's a web page access, it's going to have information that completes that transaction. So the date and time, the page they were getting, or the graphic they were getting, or the JavaScript they were getting. It's going to have a reference to what page they were on when they requested that, where they came from, what browser they're using, what response code that the server provided, either success or some kind of error. And so once again, you have to look at each log individually and look at what its purpose is. And of course, specific logs that are written for custom applications, or sometimes some of those other programs we may be running on a computer may have their own logs. But in general, it's actually fairly easy once you get the idea of logs to sort to figure out what's going on. So that, of course, leads into lesson 3. And we talk about some of the top logs, and our focus, that while we did cover and we do point out and show some pictures of Windows logs and Windows Event Viewer and things like that, once again, as we mentioned in Network Foundations, this course is much more command line and Linux based, and so as such, we're going to focus on that kind of stuff for the most part, though the principles apply regardless of whether they're Windows logs or Mac logs or Unix logs, etc. But one of the big things we talk about in lesson 3 is the basic analysis of logs. And we look at the top logs, both some of the system logs like the btemp and syslog and messages files. We then talk about some of the main server logs like access log for error log for web or email logs. And then we make reference to some additional application logs and some additional just like intrusion detection and prevention logs. And we'll look further at some of these examples as we go on. We obviously won't look at examples of every type of log. We focus on the main ones, sort of the system logs and the main sort of web and other type of application logs primarily, with a little bit of the intrusion detection, of course, thrown in as well. So what I wanted to do is in the lessons and in the exercises, we have you use either the GSN3 environment and some of the appliances therein to look at logs, or we have you use your own standalone Ubuntu machine and look at some of those logs. And as you kind of get to exploring around and looking, you'll see that there are similarities and some differences, but generally similarities across the different flavors of Unix. There will be slightly different names. For example, the main syslog file can also be referenced as the messages log, depending upon which type of distribution. And then sometimes the various web logs, they may be access_log or access log or access.log. And actually, in many cases, if not all of these cases, even though most people keep them at the defaults or some variant thereof, the reality is you could make logs, especially say web logs, for example. I run a lot of websites for clients and set up virtual host a lot. And one of the things that I always do as part of that configuration is put a custom log file in for each website. So that way it's not just one big web log somewhere that has to have to sort of filter out who's going to this site, versus each site can have their own unique log and we keep track of their own unique visitors at that level. And so, like if I was hosting xyz.com, then I would probably call it xyz.com/access_log or access.log. and whatever the format is of that server that I'm using at the time. Something along those lines. So it's pretty easy to see that, okay, this domain is and then there's a folder full of, abc.com access log and abc.com error log and xyz.access log. But they could be configured and given any kind of name. Theoretically, you wanted to. You could even, theoretically, if you were trying to keep people from who had gotten on your system from nosing around and learning more, you could reconfigure your system to have different names in different places for all the logs. But of course, a knowledgeable attacker who was in would be able to look at the configuration and then realize, oh, you called it stupid temp over here instead of access log, but that's fine. I can now go look at it. So I'm not, as usual, obfuscation only has, certain values in certain situations. So, but what I wanted to do is, while you will in the class use some appliances in the GSN3 environment to look at logs, and you will also use your own standalone Ubuntu. I am going to share a screen to a PuTTY, a shell. I hope I haven't been logged out here. Let's see if I have. Nope, I'm still on. Good. So let me, this is actually a little test server I have. You've very likely seen it before. I have a tendency to use it when I need to demo some Linux, Unix related type of stuff. And so this is just a Web2. It's not one of my active servers. At a place I used to teach, I even gave students accounts on it. When we didn't have all the years ago. And this has just been a knock around test box for me. And so I have my user over here. And so what I wanted to do though, is I wanted to give a quick tour of some of the most important log files that are on a Linux system. Now this is not on Ubuntu, this is Slackware, so things are slightly different, but nonetheless, you'll still get the idea. The log files, if you remember from Network Foundations and from your own previous experience as well, possibly and referenced in a few other places throughout the program, but the etc/etc folder is one of the most critical folders because it has all of the configuration files for servers. You'll be playing more in that in the coming days, a week or so, when you play with Snort on that appliance. Everything's in etc Snort, so you create your custom rules and your configuration all underneath there. And it's fairly common that the configuration files are all there. But if you remember, if we look at the root of a folder, the bin is where the binary files are. The boot's the boot up stuff. Etsy's the configuration files. Home is the home. I'm currently in home Lee because I logged in with that user. Library and other stuff is all kind of system stuff. The root's home folder. The secured or super user binaries are here. We come down here to almost to the very end, and it would have been the last one on the system and on most systems, except I've made a shortcut to where my web root is, and then I have a logs folder where I do, like I said, put different logs into. But nonetheless, most of the time, unless you're changing things, the stuff is underneath the var folder. Var is for variable data or variable information, and so you will find not only var log, where most of the logs are stored, but if we just take a look at var, we'll see that it has a cache, it has a DB, it has various other folders. Then there's named D, so if that's where the web server, or not the web server, named is the DNS server would keep its information. The www, that's where the web folder is actually, the root directory. But you'll see this one folder here, log. And so if I actually switch into var log, not car log, var log, and take a listing, you'll see that there's all different kinds of folders in here. But some of the ones that are kind of the big ones are, we talk about btemp. Btemp is a file that is keeps track of failed login attempts. And then we have things like the mail log. This is keeping track of the mail transactions. There won't be many. It's not very big, you can see, because this is not really a mail server. And then there is, of course, the syslog, which is system information, boot up information, and then there's messages. And the reason that you'll see both on some systems, or you'll see it all rolled into syslog in other systems. Messages has information about not only system events, but mainly like usage service events. So if somebody's logged in or logged out, you'll see. or there's been a failed login attempt, things like that. They'll all be in messages. All of these are just text files, except for btemp. Btemp is in a binary format, but all of the rest of these files, for the most part, are just text files. And so we can use the standard like more and less and tools like that to take a look at them. But of course, if we say do more messages, then we can see, yeah, this was back in April, whenever, I guess a few days ago, there was somebody trying to pound away on this, and they were just doing a brute force attack. You can see that the logs tells you the date, that tells you the time, what server, what process, in this case SSHD, so they're trying to log in through secure server. They're coming from a particular IP, and then they're using it. But you'll notice the key line here is it says failed password for invalid user guessed. And that's because this box has been hardened despite being a test box and despite allowing this to happen more than a few times on this box. It's sort of almost my honeypot too. I check out things here and see what's going on. But nonetheless, it has been secure, so only allowed users are even allowed. So even if the guest user is not allowed, and so they're trying to, you can tell this is kind of one of those script kiddie kind of attacks, probably using Hydra or some other tool. And you'll see that each one of these, there's like 4 lines that make up one actual transaction. So we're getting a little bit beyond analyzing or just understanding to a little bit of analyzing, but there's multiple transactions. So basically, the web server's logging that there was an invalid user tried to log in. That's one thing. There was an input request that for an invalid user. Then, of course, the failed password for the invalid user. The reality is, even if they had gotten the password right, they still wouldn't have been allowed in, even if there was a guest user, because it's not an allowed user. And then there's this separate message of how this address maps to this name, but that doesn't map back to that address. So probably a spoofing attempt, right? So really, we're going to block it by IP if we were going to block it. But of course, while I can hit the space bar, and this attack went on for a while, obviously. Then we had some other stuff happen, some different IPs, some more of the same kind of. See, these are now only a couple lines each. They didn't do the invalid. They have the invalid user and the failed password, invalid user, failed password, and it repeats. But they're not, whatever that other one was doing was trying to do something else that was failing and causing those additional lines. And obviously this one doesn't have a map back issue. It's just using an IP that doesn't, I guess, map to anything. But the idea is that regardless of what type of log you're looking at, as I said, it's always delimited data. So we have the month, and then we have a space, then we have the date, then we have a space, then we have the time string, then we have a space, then we have the server, then we have a space. And in this case, this mark line means that actually for a little while there on the 30th, nothing was going on. Nobody was attempting to break into this poor test box. Nobody was messing with it. And they just put a mark in the logs so that we would keep track of time and know that nothing had been deleted during that time frame. Now, if I'm trying to look for a specific thing in a log, though, using more can be a pain. If I wanted to see something today that was the most recent stuff going on, and then instead of using more, I might want to instead use the tail command. The tail command will show me the last few lines, and unsurprisingly, this box is under aggregation. It almost always is, as we've referenced throughout this program, the various botnets and script kiddies and things that are out there that are automatically happening, they're constantly happening. If a machine is unprotected, it will be taken over in no time if you leave default passwords and stuff, because they're constantly trying to log in as standard users, MongoDB, admin, root, whatever the case may be, service user multiple times. And once again, these have all been set up and they're looking for that low-hanging fruit where somebody's installed MongoDB and hasn't changed the default password. They're going to find a user and see if they can get in, and then they'll escalate from there. So if you, of course, do not use default passwords, you disallow access to people and accounts that you don't need access, then you can eliminate these types of things. But what these logs let us do, of course, is see what's going on. And we can analyze it. And we can even use things like grep. So like if we wanted to find out all the times, and we'll see if it's more than once, this 111, 230, 247.243 IP had tried something besides this one line right here. then we can grep out of that file. Well, there were 2 lines obviously related to it, and that makes sense. One invalid request and a failed password. But that's the only time that IP. Now, you'll notice that something like if we look up a little bit previously, it was all coming from the same IP. Attack, attack, attack. But then look down here. Here's a different IP. Here's a different IP. Here's a different IP. Here's a, what is going on? Well, what happens is it's actually one of the problems of botnets. It used to be easy when somebody, some script kiddie, especially from home in dial-up days or early computing days, they would do stuff from home on their own computer, and you occasionally still run into that. And you see the same IP just pounding away, then obviously you can time that out or set the policy that says reject them. We can add them to our blacklist or firewalls or whatever. But one of the things that the attackers have gotten smart about is they know that a lot of our systems, this one exception withstanding, they will instantly stop you after 2 or 3 or 4 or 5 failed attempts. And so instead of just continuing to hit again and again from the same IPs, instead they will switch every attack. This is all probably the same attacker, but they have a botnet and they've sent the instructions out, and each person, each box, each taken over compromise, whether that's a user's machine or a server in the cloud, they each take one attempt at logging in with that username and password they've been told to, and it may be the same one over and over, or it just may be one combo. But that way, then my machine, even if I had set up on this machine rules in place to block after 3 failed attempts, well, I'm not going to block any of these, aren't I? Because they only did it once, maybe twice, and then they stop. Whereas if I had a rule to block, I could block this one after that 3rd attempt, and then that would be the end of it. They wouldn't be able to try anymore. But these guys, they may have 10,000 or 100,000 or 1,000,000 PCs under their control, and then they can attack you, and you see no patterns in the IP addresses. So that's the message log. So what is system log? Well, system log has more information. It tells you error messages. You can see that it's throwing an error because it's not able, it's saying there's an error in that file. Huh, interesting. Oh, I see. But it's the mismatch between the name. In other words, maybe I tried to block this, but they're now, because they're using this, it's not working anyway. We can go on through a little bit of that error and get down to some of the other possible things. Here's an error where somebody was trying to get shadow information, the shadow password information. And so we'll see all kinds of information. This box has not been booted in a while, or you would see boot up, like the original boot up information. Now there is a special log most Linux machines have called dmessage, that you can just type. Oh, I'm not root, sorry, I have to be root. So in this case, I'm not going to do sudo because that is what Ubuntu does. I'm just going to su the user. But if I do the dmessage command, you can see that this is the log of everything that happens on the boot up. It's scrolled off the screen, but it starts to load USB drivers, and it loads some information. It mounts the drives and the file systems. It checks them, and then loads up, you know, the link for Ethernet. And then it even has some errors here. So we must have had some bad UDP requests attempted. Somebody was trying to do something from the outside into this machine. Interesting. I'll have to look into that later. That's a more recent thing. So anyway, you can have different information. And so if we then look at, say, like the mail log, we can use the more command. You'll see that there's a lot of rejection, even though this box is more wide open as a testing box than most. So that I can track things like this security scan is trying to log in through the mail transfer agent. Some other ones have been blocked, and then other ones are still getting in. And what we're seeing here, this is an example of how basically they are, if you've ever gone to work someplace and within days of you going to work there, you start getting spam. And you're like, I just got this email address, or I just created this new email address. How am I getting spam? Well, these bots will basically go out to mail servers, and they won't actually attempt to log in fully. They will pass in a username, and then if the server says, okay, give me your password, it says, haha, I know that's a username. I'm going to send spam to it. And that's all they do all day long is just hit mail servers trying to log in. And you'll see this did not issue the mail expiry verify extend. It didn't finish the transaction. It gave a username, and then it goes away. And the mail server is expecting an attempt it doesn't finish the transaction with it, because all it's trying to do is figure out whether that is a valid username or not. So once again, though, even though this is now the mail log, we still have the same model. We have a date, a space, a day, a month, a space, a day, a space, the timestamp, the server in question, what the process is, in this case, the mail transfer agent, SendMail. And then we even have a process ID for that process that was running in memory. And of course, if there's more than one line that are related, then these, so like if this was a real mail server and the user, sent a mail, and then that mail was being forwarded by our mail server to another mail server, we would see potentially 2 or 3 lines in here of our mail server talking and logging in and passing that mail, and they would all have the same process ID number. But once again, because these are just rejection or single attacks trying to get usernames validated, then we don't see repeating numbers here. Here's a repeating number. In this case, this process rejected that command, but then went on to log. Now this is interesting. Look at this. It's using the mail server. It's talking to the mail server on the mail server's ports. But look what it issued. It's trying to issue like a HTTP GET command. So it's trying to see if maybe there's a web interface to configure this mail server on that port, or actually this may even be a mistake, like the scanning tool may be misconfigured. It may be scanning mail ports like their web ports because the user didn't know what they were doing, or there's a bug in the code. There's all different kinds of reasons that these messages can show up. And then, but as so it looks like that's exactly what happened. This was trying to log in to the mail server like some of these others, but then it also passed in to the mail server's port this GET command, and that got logged, though it wouldn't have done any good because it's not a web server. If this had been given GET root to the port 80, it would have got the default web page, right? So this looks more like what you'd see in a a web server log. So anyway, so like I said, there's all these different system logs that are in here. And then if we look down into the HTTPD folder underneath var log, so now we're in var log HTTPD or HTTP daemon, then we're going to see that we have this access underscore log and error underscore log. Like I said, it can be access log, just one word. It can have the underscore. It can have a hyphen. It can be access.log. But generally speaking, there's 2. The access log shows the accesses logically, and the error shows the errors. And so once again, let's just take a look using tail at the very end of the access log file. And we can see that there actually have been a few things that have happened. In today, some people out there are different IP addresses. And so you'll see that there's an IP address of where the accesses came from, like this very last one, 46.218.35.59. It was today, about an hour ago. It basically got the home page. See that exact same command, get the root of the web server, HTTP1, and then the 200 is the success. So they were given a web page. Now, if we look up at this first line in the tail, the 27, that was earlier today about 1 o'clock in the afternoon, 1:30. And you'll see that they tried to get PHP myadmin, but they got a 404 because that was file not found. I don't run PHP admin, and even if I did, I wouldn't leave it in the default path where they could try to hit it. And then if they find it, they're going to try to break in, see if there's an exploit to it. PHP myadmin is a web tool that lets you administer, use a web interface to do some administering on a Linux box, particularly with regard to MySQL databases. And so obviously if somebody can find that interface and use your, and crack in either password, brute force login, or just because there's a vulnerability in that version you might be running. And you'll see stuff like this all the time in your weblogs, these 404s that people are trying to get the WordPress login file or the whatever login.php or, etc. And if you don't have those systems on your servers, then all you're going to get is an error message in your log. But it does tell you, just sort of like the brute force attempts, that all the time there are attacks going on and probes going on against web servers and any mail servers and SSH servers, any publicly exposed server. And so there, of course, so now we've shown you message and syslog and dmessage. We've shown you access and error. I'll show you error real fast. And so here's a bunch of people trying to find specific files. And if we look, they're looking for, there must be something vulnerable in there. PHP myadmin, various PHP myadmin, these are all very, and I can guarantee you, if they're looking, this is one of the reasons I use this server, to just sort of have it out there. And the reason many experts and defenders use honeypots in general is because if you set a box out there kind of or at least somewhat unprotected, in this case, I'm not blocking things automatically unless it's a more overt thing, and I just log all this stuff. But this allows me to, one, find out, well, I might want to block this IP from tucking into my network because look what it did. All of these attempts. And so it's doing this probably against every one of my web servers, real or test. So, this, and it also then tells me, well, there must be bugs in PHP and various versions of PHP admin because they are trying that a lot. But what is this program? What is this program? I may know them, I may not. That's not the point, but that's why I keep up. If I see that they're using certain usernames to attack all the time, then there's obviously a hole. There's a username in some service that has a default password or a backdoor password that they found out about, or there's an exploit that once they get to that page, they can hit the right keyboard combos and pass in the right string, buffer overrun, and get in. So being able to keep an idea of what they're up against, what they're trying to hit on a regular basis. PHP admin is very common, so that's not surprising. I'm surprised even in my short little snippet here that I didn't see a WordPress one, but I bet if I did WP, oh yeah, lots of WordPress. You see what I'm talking about? WordPress sites are constantly under attack. They're wonderful framework for building an easy to maintain website, but also because it's so popular and PHP based, you can see this. Even if you don't have WordPress, this server does not have WordPress, but people are constantly, day in and day out, over months, trying to hit certain files. And if they can find them, then that's a backdoor that they can get in. Potentially there's a vulnerable version there, or they've found a backup copy or whatever. You can see what they're trying to look into certain folders. And of course, many of these first round scripts like this may just be the first round. If it doesn't get, this is an error log, so by definition it got a 404 if the file didn't exist, so they didn't get it. But if they had gotten it, then they very likely would then turn around and another box would come attacking, trying to take advantage of what it found, right? So it's automatic vulnerability and then pen testing in some cases by these bots. But once again, you do all of the default things, the standard best practices. You don't use default passwords. You move, even if you're going to use WordPress, you move the login to a different place. That's actually one of the things they recommend themselves. So as you can see, as you look into your logs, and this is a great example, is one of the reasons I chose it, even though it doesn't have a lot of real traffic like users logging in and out and email transferring and real web pages. It's just, it gets this kind of stuff. And so, of course, we have good examples in the lesson of all those other types of things too. And you'll even get to reproduce some of them because you can use your own browser to hit your own web server on one, or use the browser and the topology and hit the web server. And you can see how the logs work and change. And so lesson 4, I'm actually not going to go into a whole lot here for you today, primarily because the write-ups are pretty straightforward. But basically, when we talk about lesson 4, when we go from, okay, now we understand there's all these different log files. We know most of them live here on Windows and the event viewer. They live in var log or some folder there under on Linux. So we know where they are, and we know that they're mainly text or database types of files. We understand we can use all of our tools. One of my favorites actually is, and I'm going to just go back one folder because I know I'm down here. Come on, space bar. So I'm just in var log, and what I'm going to do is, one of my favorite parameters is the tel-f, because what that does, instead of just showing you the last like 5 or 6 lines, it shows you the last lines and they stay open, so that now if something else happens, if while we're sitting here talking, if somebody else attempts a login attempt here in a second, or even if I force it by going to another window, I can basically cause that log to change in real time. So let's see. You shouldn't see this screen, but if you do, I guess we'll see. You should still be seeing the one that I'm sharing. So I've opened another console to the same machine, and what I'm going to do is just log in again. Oops, helps if I type my password correctly. So when I logged in, then look down here now, and what you see, the accepted password for Lee from my IP address, boom. And so that was in real time. As a matter of fact, in the other room, I actually have one PC that has 6 different terminal sessions, PuTTY windows, basically open to different servers of mine doing exactly this, watching key logs, mail logs, system logs, web logs. And though I have other defenses and we have other stuff going on, that pure physical, as I always tell people, if you're not looking at your logs, you're not doing your job. I live that. I'm constantly glancing up there, because if something happens and just takes off, the screen goes way faster than what I'm used to. In my traffic, I know very well. My clients are during the day, at night, they don't use, there's not a whole lot going on. Then they're back at work again in the day. And so if I see the logs just scroll by, then something's up. It's some kind of attack, or there's some kind of denial of service or error or login attempt. And of course, I want to take advantage of understanding that. If it's something different that's not going to be handled by the automatic defenses, then I can take manual defenses. I can add it to blacklist, add it to firewall rules manually. So knowing how to analyze these logs is important. But then what 4 is about is sort of taking the bigger picture and say, okay, now I have a whole, like an incident has happened, right? Like for your organization. In this case, these were incidents that did happen for organizations, and they've been, anonymized. But the idea of now we have to look in multiple different logs. We have to analyze the server logs, the web logs, different types of traffic, and then paint a picture of what that IP or those IPs were doing. And so, like I said, I won't go through the exact. There's 2 cases in lesson 4. One is a copyright and sort of identity theft kind of case that was a very detailed series of log analysis over a period of time, tracking an IP that ultimately traced to the culprit. And of course, most modern users, hackers, and especially the black hat, beyond this guy, the first case may have been borderline a script kiddie, since he didn't take some basic obfuscation, hiding himself and masking himself. And we were able to find that person out pretty quickly, or before the authorities were. In the second case, we have a SQL injection type of attack that once again led us into weblog analysis to look at how that was interpreted, to be able to see what was going on. We, in both cases, while we focus mainly on the web analysis as part of the interpretation process, actually other logs were being used in the form of system logs and maybe DNS logs and database logs, for example, as well, to correlate and collaborate this information. And as we're going to learn later, while we have all these individual logs and just looking at them and looking at them together and correlating times can tell us a lot, we're going to spend a lot of time in the later part of the class learning about the tools that allow us to bring all these logs from all these different places. So now we can feed the web log and the security log and this log and the system log and all of this into some place where we can archive those logs in case they're ever modified. We know that happened because, like an attacker got into a machine and changed the logs, but we were also in real time backing them up. Then they can change the history on that machine, but then they won't necessarily be able to change what is up on our machine if we've done it right. And so we have that backup. And so, the analysis will take you to dive deeper into logs, but then of course the tools will help you too, thankfully, because they can help surface and correlate once all that data has been brought into one of these centralized kind of network security management or STEM or UTM systems. Then we can do some analysis based on IPs or based on signatures or different things to help with that. So I'll leave those cases to mainly speak for themselves, but that's what the first part of this, the logging part, is all about, is to understand all the different types of log files, understand how they're structured, what kind of information they have, how to analyze and read them, what kinds of things to look for, Actually, some of this kind of stuff is certification testable too. Being able to identify from log output could be a question format on Security Plus or the owner, but the Cyber Analyst or Pen Test Plus type of thing. So it's important to know this type of stuff. And even if you have the tools to help you, many times you may need to, the tool may alert, hey, I see this activity, but now you need to go in and manually kind of deep dive through these files and query out with just the IPs you're in or the time ranges you're interested. And you may need to do that across multiple files. And some of the tools will help with that too. And some of them, they'll bring it all together in analysis, see the pattern, and then force you to kind of go back, even if it's through their interface, to each file individually. So the last thing we're going to talk about before we wrap up, as we run out of time here today, is a little bit more about intrusion detection and intrusion prevention. As I've said in other classes, and many times you will see them IDS/IPS, is because the reality is most vendors' products, whether that be a commercial or even our open source Snort, it's all about configuration more than it is about what it does when it comes to, and it's more about how you use it really than what it can do. Because most of them, if something can be intrusion detection, or it's just going to see the pattern and send an alert, then the odds are if it's configured differently, it can also then see the pattern and take action beyond sending the alert. If it can send an alert or send an email, it can call a system process, then why can't it update the IP tables, for example, and thus block that IP, or send a particular command through a secure means to a firewall and basically block it there. So it's all about configuration. Now, we have so far up to this point only been really doing, and to be honest, we only really will, as part of the coursework, work with intrusion detection. And that's partly a little bit of the limitation of the way things are set up within GSN3. Theoretically, we could do some intrusion prevention, and we will have an exercise to at least play around with that. One of the things you have to do is in GSN3, you have to go back and add another Docker appliance for the Snort appliance that we provided. And but you have to have it with more than one network interface, because another thing that you can do, instead of like we've done so far, where we set up port mirroring on our switch and then set up one Snort appliance to monitor all those ports through that passive back channel effectively. The other way, and the other main way that you can set up intrusion detection or intrusion prevention, is to put it in line. And that means you literally, it's in line. So if the hops through the router to the firewall, through the firewall and over to the mail server, you literally put your intrusion detection as a hop. It's a box that has two IPs. It literally needs a static route effectively, or in the appropriate configuration. And so that in effect, each time traffic is passed through, it goes through that machine. And so that machine then is in line between the outside world and the firewall. And so if it, instead of just being able to go, hey, system admin, security guy or security girl, hey, something's going on, it can say, something's weird, block that IP. And it can make an entry in the IP tables of that machine and drop that traffic and still alert and do other things. So one of the things you'll see in lesson 5 is a review of the basics of IDS and IPS. And then we talk about this inline, in-band, or passive out-of-band model. There's a number of network diagrams that just show how we can configure it. And it's also entirely possible and entirely common in certain situations and certain security needs to actually go so far as to, looks like we're not going to have any other traffic on this anyway, so I'm just going to go ahead and stop my screen share for the moment, and we'll wrap up here. But there's the hybrid model where you may have both, and we show you some different pictures of that. You get to play a little bit with that, and it's one of the things that I'll say this about it, is that as you get here and now about 2/3 of the way through the program with this course, as you head into the last part of the course, one of the final things you'll have to do is a final project, and it's kind of a red team, blue team activity. And one of the things that I think will sometimes separate some participants from others will be whether they go this extra step of taking a little more, maybe using some intrusion prevention as opposed to just detection. But I'll leave that for you to play with on your own and think more about as we run out of time here today. Next week, we are going to spend, like I said, a couple lessons on Snort. We'll talk in detail about the Snort configuration. The Snort appliance that is provided is fully configurable. The entire Etsy Snort folder is persistent. So if we make changes to one of those appliances, then it will save those changes. And if we create custom rules, we can save those. It already has a basic rule set. We'll go over all that. We'll go over rich configuration and the various rule sets that are available. And then in lesson 7, we'll cover custom rules for Snort. There are a few samples that were already in there, very simple ones, but they give you the basic ideas of a rule. And we'll teach you the rule syntax, and we'll teach you some other rules. We'll cover all those rules that are already in the system. And then from there, you can build additional rules. And then the next 2 lessons, 8 and 9, are all about NSM, SIEM, UTM, whatever you call it. These basically systems of bringing all this data together so that we can maintain a high level of situational awareness over our network. So we're not having to run around and look at every data closet. We're not having to run around and check every log manually. We can have this data being brought together through syslog, rsyslog. We can use some of these tools. And so we'll cover both some of the commercial products that are out there that do this, as well as basically, in a sense, how to roll your own and build your own using some of the open source tools. Snort is a big part of that. We already learned it. We'll introduce you to Squirrel and Squeal and Squirt and some of these other funny naming tools, but these tools will help theoretically basically do the same thing. You can we also talk about things like Graphite and Graylog, which take it another notch up in the informational and lets you centralize in database and then be able to graphically report on the output of the various systems and logs. And then last but not least, lesson 10 is about forensic analysis, and we cover a number of important concepts when it comes to how you deal with evidence and concepts like the order of volatility, etc. And then we're going to cover a number of the tools that people would use in the forensic analysis part of security, and as well as particularly one tool called the Sleuth Kit. So that's for next week. That is the end of my 5 back-to-back lectures today. And so I'm going to start the process of downloading and processing and uploading and putting them all into YouTube. And we'll get the LMS updated, and I'll see you next week. Thanks.